live from New York. It's Ask an Engineer, Zack Snyder cut now.
I'll get you, Batman. Hi, everybody. Welcome to Ask Engineer. It's me, LADYADA. With me, Mr. LADYADA. We're broadcasting live from downtown Manhattan, and we're ready to kick off another Ask Engineer.
Right. Well, I wanted to start off the show before we get into all the electronics and everything. We do a live show every Wednesday, and unfortunately, there's tragedies that are happening all the time, and we always have to process these real time as it happens. So we're terrified, horrified of what's happened in Atlanta. Obviously, our Asian American Pacific Islander community, our thoughts are with you because this is scary. There's been more hate-fueled violence and more directed towards Asian Americans in New York. It's happened recently, and now it's in the rest of the country. And we just want to let you know, like, this is our platform. This is our voice that we're saying is, like, we all have opportunities to make things better. Even in the electronics community, there's a reason, and I want to thank our community moderators and our team, because there's times where people say and do things where you can stand up and say that's not okay. And that's one of the things that we try to do with our community, is have an inclusive place where there isn't bigotry or racism or xenophobia. That's our part.
Be excellent to one another.
Yeah, and just straight up in the electronics world, there is a little bit of a vibe of like, in certain areas of the world that's cheap, it's not as good. You have to we have to actually start thinking about the things that we say, and definitely over the last year with people calling COVID locations it's from. That's also that's dangerous. Eventually something happens. So anyways, we as always, we don't want to just be a hashtag and say we're in it together, but we think the best thing is to just look around in your own life, think about the ways that you can help. There's a website, by the way, especially in communities where they're trying to get an idea of what's happening. It's stopaapihate.org. And you can check that out. Someone can post it up in the chats. And this is one place where people can have their voice heard and also report a hate incident. And hopefully we can continue to maybe work better together, live together better, because this is all we got. All right.
This is our planet.
So that is it.
Okay.
Let's do Ask an Engineer.
All right.
On tonight's show, speaking of things that we're going to have to deal with, we're still masking up, staying safe. Our team thanks you, by the way. We've been able to ship your orders. Thank you for having those come in during this crisis and pandemic. We're not done with it yet. We're tossing in the mask, as you all know. Our team, Pre-COVID Photos, thank you so much for placing orders all this time. You've been keeping us busy, keeping us in business. We're going to talk about show and tell. People on the show and tell share their projects and more every single week. Noah and Pedro are the host. LADYADA will talk about who's on the show and tell. We have some time travel, a bunch of videos this week from many of the folks in the Adafruit world, and a debut of a new series that we're doing. Got some help wanted. Python Hardware News, Made in New York City, 3D printing. We got everyone's favorite segment, DigiKey and Adafruit present Ion MPI this week, some from Analog Devices. We got new products. We got Top Secret. We're going to answer your questions, and we are going to do that.
On Discord. Join up. It's free.
Yeah, 28,000 people are there now. New graphic. Adafruit.it/Discord. All that and more on Ask an Engineer.
That's right.
Okie dokie. Let's jump right to what's happening with freebies and more.
Yep.
Because we give away stuff. We're like day 60 into the 100 days of masking up.
Yeah, we're gonna. Hopefully, by the time we're done, maybe we won't.
This is what really turned it. They'll write about this. Those
Adafruit.
That mask and those Adafruit orders. That's when we turn the tide.
They're fashionable and goth.
Yeah.
That's right. We're giving away a free mask if you order anything over $1. We had to put in some number. We couldn't put in 0 because of software. So pretty much anything you order, we'll toss in a free mask. They're very goth. When you order $99 or more, you get a free Permaproto half-size breadboard. This thing in the top left. order 149 or more, you get a free STEMMA QT board. We have a range of different boards. We've got a Cutie Pie, we've got the MCP 221 and the List 3DH and some other sensors. And when you place an order, we'll give you a random one. If you have an account, we'll give you a different random one each time, so you don't get the same random one, although that would be a weird coincidence. For UPS ground shipping on orders $249 or more, $200 or more, and $299 or more, you get a free Circuit Playground Express or all-in-one development board. No soldering required. People love them for learning how to code and make with all the hardware built in.
Okay. And we're going to be doing that until things change, but you can always check adafruit.com/free and see. But these are going to be the ones, the mask, another 40 days probably, and then these will probably have until further notice. So go get them. All right. Show and tell. People around the world showing and sharing their projects. Noah and Pedro were hosting this week. Thank you, Noah and Pedro. Next week, Lady and I are back. More who is on the show and tell this week and what they share.
Glad you asked. Thank you, Noah and Pedro, for hosting. JP hosting, I think, last week. Kicked it off. We were not in order, but Kevin from DigiKey came by, showed off this week's new release from DigiKey. Not sneezing. That was just me. That would be cool, though. It's just like, if you get sneezes now on cut tape. No, they have cut tape components. If you get your parts on paper cut tape, you'll have a printing on the back that'll have the part number and the value and your PO, like all that detail, like a little receipt. Very handy.
We talked about this on
Desk of LADYADA.
Desk of LADYADA, too.
Check out the video. Also, I saw Sean post up some images. You'll see people start posting pictures of this. It's free. You just get it whenever you order something with paper-backed cut tape that's 8 millimeters wide, which is like resistors and capacitors. And this is great for 0402s and 0201s because they're so small. There's no markings ever, so like, you really don't, you're like, what is this mythical tape? Like, I have tape, I'm like, I don't know what this cut tape is, but I'm scared to throw it out, right? That's what happens. Brent came by and did a live whippersnapper demo. This is our cool no-code add-on to Adafruit IO to let people plug and play our Wi-Fi boards and have them automatically controlled through the website. You can start like coding them and controlling them. Jepler wrote a guide on circuit sculpture and came by and showed off some of circuit sculpture. JP is working on a cool touch deck using the RP2040 Feather and a TFT Feather Wing. Thanks to Foamy Guy for helping out. Scott went through the Open Hardware Summit goodie bag. If you were going to attend last year, but you didn't, obviously, because it was canceled because there was a pandemic in New York City. You got your goodie bag now, and they're going to be sending out another goodie bag soon for the upcoming open source hardware event. The goodie bag has CircuitPython hardware in it. It's got this Osh watch, I think it's called. It's an open source hardware watch that uses the NR52840, so you can upgrade your CircuitPython because it's like a year out of date, but then you can get the latest Bluetooth apps and demos that we've got.
It's like a little time capsule of what we were doing last year.
Ding dong!
And you can use the watch. You probably want to update it.
Yeah.
But the other thing is the Open Hardware Summit is coming up soon, and they're doing it virtual again, and we have something in the goodie bag this year. So if you're thinking about it, that'll be in there soon.
Freebies. Micah came by and worked on a birthday present for their sister. It's a constellation light. I guess the sister is a Pisces, and so the lights are like there's 16 lights, and they show the Pisces constellation, and it's done in NeoPixels. It was all hand soldered. They did a great job, and that's the best kind of present. It'll last a long time. Electronic heirlooms, as it were. Mark has a problem. People keep driving past his house. They don't see the house numbers. So he's going to make them out of NeoPixels, light them up so people can see them. Michael's working on an Iridium satellite messenger, like text messengers, or to show off showed off some pictures, and some TFT revisions that are being worked into the next version. Mohib is working on automaton hacking. It's like this cool slide whistle, electronic slide whistle from Japan. They're super funny, and they are in a lot of good memes. They have to be hacked and connected to electronics, so this is cool. There's apparently multiple versions. I did not know the genealogy of automatons, but I will look it up. Andrew made a Geiger kit from Adafruit and then used it to test stuff around the house and found out that a lens for his camera was actually kind of radioactive and kind of scary. And then Liz is working on a Sailor Moon Locket prop. So everyone wants to be Sailor Moon.
Okay.
True. That was show and tell.
Every single week, 7:30 p.m. The longest running show and tell online. It's part of our Adafruit live series of shows. If you're watching this right now, it's Wednesday 8 p.m. Ask an Engineer. Show and tell every Wednesday 7:30 p.m. Eastern Time. And it's part of our Wednesday shows. On Sunday, we do Desk of Lady Ada. Lady Ada this week on the Desk of Lady Ada, you showed that cut tape thing.
Yes.
You talked about that.
That was great.
You also showed this DVI
Gigantic
thing.
ebon heads.
Yeah, so it's a cool video. If folks are interested, check it out because it had
Gigantic ebon heads.
a preview of some things that you're working on.
Yeah, I've been doing a lot of keycap stuff. So I showed that off. I showed off this DVI breakout board for the Pico. And one of the demos that it runs is this gigantic bouncing ebon heads with Raspberry Pi logos.
This is our first feather that can do stuff like that.
Yeah, this is our, this was the Pico that I had because they had a pre-compiled version.
Yeah, but we have a feather.
The feather will be able to do
RP
absolutely as well. And yeah, I was thinking actually one of the things I was chatting about was maybe making a DVI feather wing.
Yeah.
It would plug in and it would give you DVI and I2S audio just for the RP2040 because like nothing else can do this like ridiculous hacking. But then you could like play movies from your feather, like very short movies.
Well, we say that now, right? That it's, very short movies. But I remember having an MP3 player and being able to play like 3 songs.
Yeah.
Like, just think, where is CircuitPython going to be 10 years from now? Right now, we're joking about having video and little audio. It'll be whatever version of HD there is.
What was the name of those MP3 players everybody had? It's like Nova Blues, or there's some name of them.
Yeah. Someone in the chat will.
Somebody. It was before the iPod, and I remember that it was like, this can hold an entire album, and I was like, this is amazing.
Yeah.
Yeah, I don't remember the name of them.
Nomads?
Probably
Nomad player.
MP3 Nomads. Yeah. So I think I remember the first ones, and they were like so cool.
And we're talking about the first feather right now.
Yeah.
March 17th, 2021. That can do video and audio out like that.
Yeah.
We'll be able to look back at the show a year from now and a year from now and a year from now. And
when we have like the Pico implants and like the wetware, like cyber.
Well, I think, the chips will they'll continue to be more powerful, and we'll be able to have Adafruit open source versions of a lot of things that are like nearly impossible to do right now.
Yeah. Also makes me want to redo that, like, the Pico to Zero converter that I did. Remember I did put that together. I kind of want to do it now, but obviously I couldn't use the Pico anymore. I'd have to use the raw chip, but it would have HDMI output because, like, it has DVI output. That'd be such a fun little hack.
All right. And then we also...
Where in the world is that part I need? The Great Search with DigiKey.
Did the Great Search with DigiKey this week. It was...
It's a replacement for our favorite, but now completely, utterly discontinued STMPE series resistive touch control panels, resistive touch panel controllers. We use them on a lot of our boards. We basically bought the last reel, and we got enough to kind of like keep us going for a few months. But this chip really is discontinued, so we have to find a replacement resistive touch controller for resistive touch displays. We wanted something that was either I2C or SPI, ideally both, and one that had Linux kernel drivers. So you can take a look and see what we came up with.
All right, and the chat has spoken. It was the Creative Nomad.
Creative Nomad, yes.
What was that?
I'm still traumatized by the real player buffering. So like,
all right. Yeah. Every Tuesday we have a show, and this one is JP's Product Pick of the Week, where we broadcast live from the product page. One day we'll be broadcasting live from the product page,
Pico.
and the whatever Feather CircuitPython iteration there is. Maybe you'll be able to watch it in, after you mine enough coin for it. But
JP's next one should be an NFT for sure.
Yeah. So JP's Product Pick of the Week. Here's the little the 1 minute overview segment. See you on the other side.
It is the PCF 8591, and it is an 8-bit ADC and 8-bit DAC on a board with Stemma QT. Got a cyber deck plugged into the GPIO pins of this Raspberry Pi 400. This Raspberry Pi is running a little Python program that uses the CircuitPython library for this board. It reads all 4 of the analog inputs. What I'm doing is tracking the first knob here for the X position, the vertical line here with this second knob. Third one we saw, that's changing the hue. And then the last one is brightness. So you'll find I can get that pretty zorching bright there, or drop it down way low, or all the way off. It is the PCF 8591 8-bit ADC and DAC in STEMMA QT format.
All right, and this Thursday, tomorrow, is JP's workshop. And I'm going to show the screen thing one more time because someone on Twitter was pretty nice. They said, oh, they followed the tutorial for the RGB light and the reflective thing.
Yeah.
And it didn't work at all. And they were frustrated. And, I was reading this. I'm like, oh, no, we're going to get blamed for everything. And they said, oh, there was protective coating on it.
Yeah, because it's like the microbeads
Yeah,
are
so
delicate.
public service announcement here.
Remove the protective coating.
There's sometimes protective coating on things.
You have no idea
And-
how many people email us and they're like, my TFT screen is damaged, and we're like, what's
Yeah.
the damage? And they're like, there's this like marking on it, and I'm like, yeah, there's this protective plastic, and that's the marking to let you know that there's
EL
a protective-
panels, yeah.
EL panels.
I've probably
Yeah.
answered 1 million emails about EL
Yeah.
panels. They're like, this doesn't look like the picture, and it's like you have to peel off the thing, and they're like, sorry.
Yeah.
And sometimes it's full on anger and upsetness because when you're at a computer, you don't think about who's on the other side. And then sometimes people are just like, oh, like, whoops, sorry, they're nice about it and everything. Anyways, so I wanted to show the video of this because I think this is going to continue to be a project that people make because a lot of people are streaming and doing stuff from home.
Yeah.
And then I'm going to do a preview of something JP is going to show this week, so I'm going to play this back to back. Okay, time travel, looking around the world of makers, hackers, artists, engineers, which stuff's going on, reminders, and more. So
Yeah.
we just updated more of our gift guides. So
Okay.
gift guides became so popular during certain times of the year where people give presents and stuff. They're like, well, can you just do gift guides all the time?
Yeah, birthdays
Yeah.
and
So
graduations.
so check out the gift guides that we're doing. We're publishing new ones all the time. You can
Oh, that's
go to
cute.
Adafruit.com, yeah. And we have Raspberry Pi gift guide that we're going to either publish or publishing shortly. Adabox.com. You can sign up to be notified. We do a subscription service. Every 3 months or so, you get one of these boxes. We'll probably be shipping out April, May. There's openings probably after we charge credit cards, and then sometimes there is.
You will get notified. Chances
Yeah.
are, if you sign up now, you will get a chance to subscribe right as we're shipping, because there are openings that people can't, they cancel right after we are charged their card, or their
Yeah.
credit card doesn't activate or whatever. And so we have 50 openings, and then we notify everybody. So do sign up. We absolutely do notify people when we have slots available for them.
And the plan after, and I hope we continue to see signs of recovery, is maybe add more in 2022.
Yeah, we couldn't add more subscribers. It was too much.
Yeah, and still right now there's logistical challenges from shipping to chips. The world has not restarted
You can't
yet.
get displays, but
Yeah.
we're moving around our ADA boxes to make sure that we can fulfill them. It's just it's a fun challenge, especially right now. There's a lot of things that are unavailable. Anybody who's doing electronics or purchasing for engineering knows, like, you just can't get chips anymore sometimes. Or you can't get displays, or you can't get some sensors. So don't worry, things are happening. We're just surfing this wave of globalization, shipping stuff.
All right, other bits of time travel. Got a video from Paint Your Dragon about the feather silk, and then I have a video from our air quality monitor that we had a guide, and I finally got that out.
Yeah.
So we're going to play those two, and then we have a debut of some videos from Colin. I'll talk about that right after the break.
So here's this board we brought from Eagle to Illustrator. Got some notes on the right. Hey, it's the hot new chip, RP2040. I've isolated certain silk from the Eagle file, and then I've brought in an earlier design from the Feather M4 as a starting point. Text baselines and sizes are reset, and then pin numbers are updated for the new chip. And then lots and lots of shuffling and nudging and resizing. Shuffle, shuffle, shuffle. Nudge, nudge, nudge. This is about an hour's work here. And then I remember, oh yeah, we get to use that official new logo. More shuffling, more nudging. Shuffle, shuffle, nudge, nudge. And here's what the final board will look like.
Early data, what is this?
Hey, I'm testing out some code from Carter. He made a CO2 sensor. This is a IR CO2 sensor, so it's a true CO2 detector that detects parts per million. And this is a matrix portal, which is from our old Ada box a couple months ago, and an RGB matrix, and it's showing off the ppm and telling you if there's enough ventilation in your room. We thought this would be a cool project because we're seeing a lot of teachers and students, they want to build something like this for their classroom or their workspace, so they can tell when it's time to open up the windows because they need more ventilation, or when there's enough ventilation and maybe they can close the windows a little bit. So I'll try it out by breathing on it. And you'll see it goes up from 800 to pour over 1,000, and when it gets up a little bit higher, it'll even warn you, hey, you really have to open the window now. So this is a cool all-in-one CO2 detector.
All right. A lot of folks are familiar with Colin's lab. This is all back when I worked with Colin at Make. And when Colin joined Adafruit, we started and restarted Colin's lab, Pseudorandom, and then the Circuit Playground series. Now, during the pandemic and more, obviously we decided, well, we're not going to film puppets and stuff together because it's like really...
You get really close.
We're just like, we'll get to it eventually.
Yeah.
And so we paused that. But one of the things that we had started and now restarted is, and also time change, and the formats changed. TikTok is now here. So we also thought, like, the attention spans are short. And that being said, especially young people, they want to learn things on some of these platforms. So TikTok is like, it's a story place. You're telling you're showing something you make. Or like on Instagram, it's like, here's something I have. Twitter, here's something I'm going to complain about or say.
Yeah.
And so what we decided to do is make these Colin Lab shorts, these Colin Lab notes, Colin Lab snippets. And with these, I'm going to play, let's see, 1, 2, 3 of them. They're a minute each. 3 in a row. And you'll be able to get an idea of a concept or how something works or what something is very fast. So here we go.
Take it away.
The tactile momentary switch. It's the button backbone of PCB user interfaces. Available in a variety of form factors, tactile switches are probably most recognizable as the ever-present reset switch on a microcontroller board. But you probably don't realize how many of your devices actually use them, as they're often hidden behind a front panel. Tactile switches are convenient, but wiring them up can be confusing, because it's easy to forget which pins are connected which way. Was it these two are connected to each other? This one? If you don't have a multimeter handy, just solder to posts at opposite corners. Those will always be disconnected until the switch is pressed. Easy. Nearly as important as solder type is solder thickness. If it's too thick, you'll have trouble with tight spots and small devices. If it's too thin, you'll have to keep feeding solder into the joint, heating the pads longer, and possibly damaging the board or part. So, which size is right for the job? Delicate surface mount components are best soldered with thinner gauge, generally around 0.02 or 0.015 inch. It's like the angel hair pasta of solder, except shiny and very toxic. For through-hole soldering, 0.031 diameter will do the job well. Your soldering will go quickly, and there's plenty of flux inside to give you good, clean solder joints. For large components, you can go up to 0.062 inch. But if you get thick solder, just make sure it's the electronics type and not plumbing solder. Through-hole resistors are so commonplace that you likely don't notice their unusual aesthetic. So why are they the only component that displays its value using painted stripes? In the early days of electronics, printing tiny numbers on little cylinders was a relatively costly process. To keep costs low, manufacturers established the resistor color code and used simple stripes instead of characters. Capacitors got a similar treatment, often using dots and resulting in a decidedly funky look. But only resistors still use the color code today, and that's because the system works so well. The stripes can be read quickly from pretty much any angle, and unlike a text label, they can't be hidden by installing the resistor flat on a PCB. And that is how the resistor got its stripes, and kept them.
Okay, and stay tuned for more of these. We have a bunch lined up. LADYADA and Colin are working on them. And
send in requests if there's something you want us to cover. We do be kind and post, up in the comments of the Instagram or on YouTube.
You also have the hashtag Colin's Lab Notes.
Yeah, and then we will take those and add them to the big stew of ideas. And then when we fish out a vegetable or a chunk of meat, we will maybe fish out your idea.
All right. Help wanted, jobs.adafruit.com is something right along. And there's really cool jobs that you can get, and there's skills that you can post, yours. We moderate each one of these. We make sure there's no scams or anything weird. This week's job that was just posted, Makerspace Manager in New York, New York. It's a full-time position.
Mac
check
inspires.
it out. Yeah, so check it out. Jobs.adafruit.com. All right, let's do some Python on hardware news.
Okay. Blinka, blinka, blinka. Okay.
All right, before we dive into the newsletter, this is an item in the newsletter, but I wanted to just read what the editor-in-chief of Tom's Hardware said. The Adafruit Feather RP2040 is the best RP2040 board you can get. That's the review. There's more. Offering 8 megabytes storage, strong battery support, 4 ADCs, and a huge ecosystem of add-on boards. Get it if you can find one in stock. Yeah, that's the only problem right now.
Believe me, if I can get these parts delivered to me, I will make them. I'm waiting on 1 or 2 more shipments.
Yeah.
It's funny, if you don't have the part, you can't substitute another part. Like if you don't have the USB-C connector, nothing else will fit. You got to have that connector. So
and
hopefully soon.
Just another thing, we decided not to do back orders because everyone, especially in the electronics community and the chats, are talking about this right now. There is some part delays, part storages. Imagine if you take someone's money and then indefinitely you're holding it for maybe these parts. So we do sign up. So sign up. We never do anything else with the email. You only get one email when it's back in stock, and then you place an order. And that's been working out. So that's what we do.
That's right.
So sign up for them, and we're going to make them as fast as we can.
Correct.
So that was the hardware portion of it. And I think, and I'm just going to say this, it's, yes, the hardware, you did a good job.
Oh, thank you. Thank you.
Additionally, it's not just the hardware, it's the Circuit Python
it's the community
world.
It's the code and the community.
Yeah, this is Code Plus community, but the hardware is really good. And the thing that people can code with is it fits the hardware well.
Yeah.
So Feather, open, does all these things. Huge ecosystem of hardware, Circuit Python, hundreds of libraries, get you going really fast, and you're doing the thing you want to do.
Yeah.
So Anyways,
Never
and
understood why these cutting boards had circles on them. Like, what's the goal? What are you doing?
there's probably some type of thing they use there.
What are you doing?
So
Okay.
that is so that's that.
Okay.
So the other thing, we have our Python on Hardware newsletter.
Yes.
Um,
Piper Make.
yeah.
A new Chrome browser-based, fully browser way of doing block-based programming. And guess what? Underneath it's CircuitPython. You load CircuitPython, and then it basically turns the REPL into a block-based, like Blockly programming system. There's even a library that they published, which we've just added to the bundle today. So you can even basically take your Piper code and then make it like permanent, living on the storage device. So it's interesting. I think this is cool. I mean, with Web Serial now being a standard, it's by default on in Chrome. You don't have to enable it anymore. One of the things I always wanted to do was have a web REPL, and I'm like, they did it. Like, there you go. That's CircuitPython.
Yeah. And the neat thing is, if anyone says, well, Adafruit, are you going to make it like a block-based CircuitPython?
These guys did.
Here you go. And
I don't have to.
yeah. And so this is really neat. And I think that, if you make code with Circuit Playground Express, try the Pico, if you have one, with make.playpiper.com.
That's right.
So anyways.
Check it out.
Yep. Okay, our Discord server hit 28,000 people. Right
Yay.
now we have about 4,704 people online.
That's nice.
Yeah.
CircUp, we're doing a bundle managing and library management. We're going to see some work being done with that. We've hit 300 libraries, so we want to now write plugins for IDEs to make it easier for you to manage your libraries. Thankfully, we all thought about this years ago, and we said, like believe me, we had a lot of discussions about the libraries. If you look at how our libraries are done and distributed, it was designed to be automated and turned into a fully automated way of publishing libraries and getting them into IDEs and managing all the dependencies. We learned a lot from how Arduino did it, and we just want to skip to what Arduino is doing now and not have all the pieces in between. So, I know folks are you can always drag and drop the files of your libraries onto the CircuitPy drive, but it would be cool if maybe Thonny or Moo or VS Code did that automatically. So that's one of the things that we're starting to work on now. So keep your eyes peeled. And if you want to contribute, if you want to help write a plugin for your favorite IDE, post up in the Discord or join us on GitHub, post up an issue, and we'd love to have you because there's a lot of IDEs, and we're going to do some big ones, but we might not do all of them.
Yep. By the time the next newsletter comes out, there's a new update of Moo. I think we either got in there or it'll be in the next one.
It's a public beta. Yeah, we're stuff's in there, but we have some improvements. Hopefully we'll get in before the last beta.
Yep. Deep Dive with Scott this Friday, 2 p.m. Check it out. LADYADA stops by sometimes
Flash
too.
memory.
Talks about CircuitPython. Here is more of...
It's a round display.
Yeah, we're seeing more round displays. And one of the things that folks do with CircuitPython and also all forms of coding on the Pico is display things. So you can see.
Yeah. So round displays, and it's cool because you can see the capabilities of CircuitPython, which is managing all these are objects, you know what I mean? So you don't have to redraw you don't have to deal with dirty rectangle tracking. That's all done for you. You've got some keyboards. These are running. These are from
lots of keyboard stuff.
They run CircuitPython. This is a cool demo. Somebody just showing, hey, look, all these CircuitPython all these devices, I2C devices and displays have CircuitPython libraries already. Isn't that wonderful? Gameduino, I love what they're doing. They're using the Eve chipset to add true HDMI. I mean, the Pico is doing this cool hack, but this is true HDMI output with full graphics support in CircuitPython, so you can load sprites and play videos and resize and perform. It's like a GPU basically for microcontrollers. They have a shield and I think a feather wing, and we're going to hopefully stock it soon.
All right. You can
just
check
some
out some more
CircuitPython examples.
vids. Yeah. Bill, he was on the show and tell and showed the RP 2040 head mouse.
Yeah.
So that's a standalone video. You can also check out last week's show and tell.
Connecting hardware to hardware, making synthesizers.
Yeah, there's a lot of MIDI stuff going on because we have that for CircuitPython. So people are using the Pimoroni keyboard to then control MIDI stuff.
Yeah, this is Jepler's WWDB clock.
Yeah.
TG Techie's working on doing GUI stuff with CircuitPython display. There's a lot of GUI
That's
stuff
all
happening.
you need to watch to do.
On, off. So like, what do you need more? Who needs to know the time?
Yeah, you just need to know, are you on or are you off? All right, and so
So
you check out.
MicroPython projects,
Yeah,
Blinkas,
so you can check
Touchlands,
out all of this stuff
and more.
And more. We also have a roundup.
Dude, this is a huge newsletter. I haven't even read it.
Yeah,
I gotta
we also have a roundup of some of the things we released, and also the upcoming events. Up to I think 305 libraries. Let me check. 305. Yeah, 305
Good.
libraries.
Yes.
And check out the events that are coming up. There's Open Hardware
I
Summit,
think PyOhio's coming out.
GeoPython, PyCon, EuroPython, PyOhio. Some of these are virtual. Some of these are going to be in person. Stay tuned to the newsletter for all the things in Python. And that is this week's Python on Hardware. Okay, LadyAda. We are an open source hardware company. To prove it, we post our files.
And
We
our
post
guides.
our code. We post the guides. We post the videos. All 2,435
Yes.
guides. Are
So
up.
if you go to
new?
learn.adafruit.com and you look at the new guides, you'll notice we also have updated guides. So some of these are not, you'll be like, hey, wait a minute, the Metro Airlift, that's not a new product.
Hey, wait a minute.
So we update guides. We want to tell people when they've been updated, especially if it's more than like typos. So what we've done is all of our M4 airlift boards, we really revised all the instructions on using the airlift. We now have a templating system in Learn. We used that to basically refactor our airlift tutorial pages, how to upgrade airlift boards, how to use them. And it should be much, much, much easier now. Instead of having one shared page, each product has its own wiring and code. So it's going to be a lot easier for us to maintain, a lot easier for people to use. Our Learn system is a content management system, and it's not trivial. It's a pretty intense one, but we're always looking to improve. We want to have a really good documentation. I think we're like the leaders in good electronics documentation, making it powerful and maintainable. That's the dual challenge, right?
Yeah.
Because if you have a lot of documentation, it's not maintainable. Things change. I mean, like Arduino's constantly changing, CircuitPython's constantly changing, Python is constantly changing. We have a lot of Python 2 projects. We got to go back and like revise them for Python 3. So just letting you know why there's these airlift boards.
Yeah. Here's one request I have for the community.
Yeah.
So, a lot of hardware that's out there, just goes back to, I think, just being good to each other. A lot of hardware that's out there, it might be like clones of ours or whatever. And then sometimes there's different versions of similar hardware that we have, and the other companies will just take our code and take our names off it, but sometimes they link to us. Here's my request: is when you buy hardware from Adafruit, or if you're shopping around and you buy and you're not going to buy from somewhere else, but it's because of the documentation and code, let the other companies know. Just say, hey, like, I was going to buy this product, and yeah, yours is maybe cheaper, or maybe sometimes it's more. Usually, because I think we do a good job with pricing.
Yeah.
Sometimes there's things that are more expensive that don't have any documentation versus something that is lower cost and higher quality and has all this code and all this stuff. One of the things you could do, and do it politely, is just say, hey, like, when I shop for electronics, I like to buy from the places that publish the code under an open source license and then also have some type of documentation. I think that's like, if everyone started asking that, everyone would do it, and we would even get better at our documentation and our stuff, because the expectations would continue to go high. I think we do a really good job, but I think we need more people doing it. We need more companies doing it.
Yeah.
See that a lot. All right. So speaking of documentation, what else you got this week?
So the guys that are live this week that are new is Melissa did the 2.13 inch e-ink display breakout and featherwing. So we've pulled out all of those e-inks and they've given them their own guide page. You've seen a lot of those being revised, so that's part of it. A lot of e-ink displays are discontinued. We have to update the products, and so having the guide hopefully will try to make it as easy as possible to communicate which code you have to use, because physically they all are all the same size, but the driver chips inside them is different. This is unlike TFT. TFT drivers chips don't change that often. We did upgrade the RGB LED matrix with CircuitPython guide quite a bit. We added the Pico and the RP2040 support. So if you want to use RGB matrices with the RP2040 Feather or the Pico, check out this guide. We have wiring diagrams. Jeff Epler also did a guide on your very first circuit sculpture This is a way of making electronics by soldering very thin brass wires. So this is a very basic early project. You make a capacitive touch heart. We also did some updates to the Adafruit I/O guide. Again, I think we just cleaned up a bunch of stuff. And the AMG 8833 guide got updated because it's now a STEMMA QT sensor.
All right, more guides ahead. Let's do some factory footage. Here is a time lapse of us. You can see we're wearing masks, staying distant.
Staying distant.
And
Use
this
machines.
is on top of the oven. And over there are the
And you
two
can see the
pick-and-place
windows are
machines.
open. That's why they're kind of, the blinds are...
Yeah, our building was built after the previous pandemic, so there's windows and radiators surrounding all the...
Okay, this is testing
rooms.
Halloween M4s. This is what it's like. Glowy skulls. Who doesn't love a glowy skull? So the pick and place running, manufacturing something. What? I don't know. These are the reels. So the cut tape, the tape and reel. As the day goes on, the feeders and the cover start kind of growing like hairs.
Tray straps.
This is how you should package trays. Ask us how we learned that you shouldn't use rubber bands. Use straps. We've got some GPSs that fell off of the cut tape we have, but they're like $10 a piece, so we don't want to toss them. So we laser cut a little tray, and we put the 20 or 30 modules we had, and we recycled them. Checking out these cool reverse mount LEDs. Now look at how they are in the tape. They're upside down. Yes, that took quite a bit of convincing to get. But what's cool is that these will be reverse mount LEDs. We're going to use these in some of our keycap breakouts.
All right, and with factory footage, we have some photos. This one, if you look really close, you can see Freedom Tower there.
Yeah.
This is right down the
near
street
New
from
York,
it,
yeah.
from us. This is the Disney building across the street.
Never stopping.
No. And this time they're moving around some gravel.
Yeah. Okay.
And it wouldn't be...
Looks like they had some concrete down.
Yeah. It wouldn't be an Adafruit factory footage segment without a sunrise or a sunset. Okay, 3D printing. Pedro? Printing up Storm.
Plus Liz this week.
Yeah, we've got 2 videos. We're going to do the Pico MIDI project, and then we're going to do a speed up of your GitHub repo,
Yeah.
which is kind of cool. Which is scary.
This is
Because
scary.
it's all green
Yeah,
pastures.
you can kind of tell it's like the weekends don't really, there's some people you can see there's this beautiful green stripe, and it's like Saturdays and Sundays. They obviously,
Yeah.
for me, Saturdays and Sundays are actually a little bit greener. But,
I was doing so much stuff in GitHub.
I don't do a thing where I'm like every day. I don't care about the everyday, but there is many greeny dots.
You could tell the exact day I had to stop all the things I like doing
Yeah.
and work on all the things that had to get done. Last year, right when the pandemic started, that's when I stopped being able to do a lot of stuff I was doing in GitHub, from our newsletters to more. I was really active there. But anyways, so we'll show that speed up too. So now, Pedro, take it away.
Okay. See you on the side.
Hey, what's up folks? In this project we're making a MIDI controller with arcade buttons. This uses the Raspberry Pi Pico to make a USB MIDI controller that features 16 LED arcade buttons. The Raspberry Pi Pico is a low-cost microcontroller with a powerful new chip, the RP2040. It features tons of GPIO and it has CircuitPython support. The AW9523 is an I2C GPIO expander and an LED driver that features 16 I/O pins. This lets us drive all of the LEDs so we won't run out of pins on the Raspberry Pi Pico. As a native USB MIDI device, it can work with both hardware and software that have MIDI support. The electronics are housed in a 3D printed case, and it features a handle that doubles as a kickstand. We designed the case in 3 parts that snap fit together so it's easy to pop it open and close it up. We think it looks a bit like a lunchbox. What makes this different from other MIDI controllers is the ability to change and save MIDI notes directly on the device. It features an OLED display and a joystick so you can quickly remap MIDI notes, which is great if you're crafting your own setup. The buttons are shown as circles with numbers that represent the MIDI notes. You can use the joystick to select a button. It works just like a D-pad from a game controller. You can press the center of the joystick and select a button to edit the MIDI note. In edit mode, the button will blink, letting you know that it's been activated. You can then change and update the note to go higher or lower using the joystick. While in edit mode, you can also press the buttons to compare the MIDI notes. The handle is 3D printed as a single part, and it features 2 built-in hinges. It's a print-in-place part that doesn't need any support material. The hinges are able to freely rotate, and it features mounting holes for attaching to the case. You can get the parts to build this project, links are in the description. Let us know in the comments if you'd like to see this available as a kit. The parts can be 3D printed without any support material using PLA filament. We designed the case in Fusion 360 and used 3D models of the electronics and components. It's a parametric design that features user parameters, so it's easy to make adjustments. We've open sourced the design so folks can modify, remix, and customize it. The code for this project was written by Liz Clark. You can check out her projects on her YouTube channel, Blitz City DIY. This uses the MIDI library for CircuitPython, and it features lots of comments, so it's great for folks who are just getting started with programming. The code walkthrough by Liz is very well documented, and it breaks down all the features so you can learn how to customize it. We hope this inspires more folks to get into programming electronics with CircuitPython. Be sure to check out our Learn Guide for a full step-by-step tutorial on building the project. The Learn Guide has the code, wiring diagrams, and CAD files so you can follow along and make your own. Thanks so much for watching, and don't forget to subscribe for more projects from Adafruit.
And tune in every Wednesday for 3D Hangouts with New and Pedro.
Hi.
Hello. It's time.
It's time.
DigiKey and Adafruit present This week's Ion MPI is from Analog Devices. Ahead of what's possible, LADYADA. What is the Ion MPI for this week? Brought to you by Adafruit DigiKey.
Okay, yes. This week's INPI is the AD5413. This is a SPI DAC chip, and when I check this out, like I normally don't use these kinds of chips, but I can immediately tell what a great design this chip was. And so the people who are watching, who do industrial automation, or anything, you know, with architecture or building management or PLCs or, you know, mechatronics, all that stuff. If you need a DAC, this chip is a really, really nice DAC. You know, I've used SPI DACs for basic audio projects, and so when I saw the capabilities of this digital to analog converter, I was like really impressed with the care that I could tell ADI put into this. So it is, you know, a DAC chip. You solder it onto your PCB. It's you know, got one output. It's a single output. The output can be either current or voltage. You clock in data to set that voltage or current. Simple, right? But there's a lot more going on. So the first thing that I noticed about it that was really neat, you can read all the specs about it, is it's got a very wide voltage range for the output. So the power of the chip, I think, is like 4 or 5 volts or so. But the output voltage, right, usually that swings between 0 and VDD, whether it's 3.3 or 5 volts. But in this case, it goes to between plus or minus 10 or 12 volts. So, you basically can give it a split supply input, and it will give you a full sweep range output. So you can actually even see, the op amp there and the current buffer as well. It's a 14-bit DAC, so it's pretty good quality DAC. You get plenty of bits. It's not like an 8-bit or even a 12-bit, which is what I've used. But 14-bit, which is really nice. It's got an R2R ladder inside, which you don't see here. And then it will automatically do all the op amp, gain management and offset tweaking that you can do. You can even set offsets inside memory if you need to calibrate the output. And, beyond just the fact that you can set the output voltage between negative 10 and plus 10, or negative 12 and plus 12 if it's, you go over, there's a little bit of an over voltage setting. It's got a lot of like extra details and built-ins that kind of fill it out and basically make this, in my opinion, if you've got something that you need to have an analog output to, you don't really need any other chips. Like, everything is super integrated. So this is perfect for people who are like, hey, I'm a hardware or firmware developer, and I don't want to learn analog. I just want to get this voltage output to bias something or control something, or to interface with some analog input circuitry or current input circuitry. And I just don't want to deal with all the messy stuff in between. And with this, you don't have to. It's like you're pretty much like, maybe you need a resistor or capacitor too. It's pretty much ready to go as is. So the input is 32-bit SPI data. Unlike most DACs where you have you basically just write the data to the R2R ladder and that's it. This has kind of a structured input. So the first bit is just like a start bit, basically, to let it know, like, hey, yeah, start listening. The 2 bits, D30 and D29, are the address. This I thought was interesting. So kind of like I2C, you can have 4 of these devices on one SPI bus with the same chip select line, and each one of them can be addressed separately. So you can set the SPI address. I haven't really seen this being used with SPI. I've seen this more with I2C, but it's the same idea, right? You can have 4 of them on the same bus. Not sure exactly, why you'd want that versus having multiple CS lines. Of course, you can always have multiple CS lines as well. Then there's the register address. That's 5 bits. And there's a register, so you can actually send it multiple commands and read data from the device as well. And then you've got the 16 bits of data. The bottom 2 bits aren't used because it's a 14-bit DAC. And then there's a CRC, which is really nice. You don't have to worry about, what if I'm in a high noise situation, or maybe my signal lines are flaky, or connector gets connected, disconnected. The data comes in corrupted, and there's some chance of accidentally setting the DAC to the wrong value, which could mess up your robot or mess up your PLC. In this case, you have a CRC, so you have this extra level of QA redundancy on every command that you send. And I think that was, again, it's a nice little add-on, right? Because I don't see that often on SPI devices, and definitely not on writing. I usually see that on reading, like when you read data from a sensor, but I rarely see it on writing commands. So a nice little extra there. And these are all the registers. They have stuff like a chip ID, which I thought was nice, and device ID. You can read all of these. There's not a lot of them, mostly configurations, and then you can see the DAC output register itself. But basically, you can treat these sort of like I2C SM bus registers, and you read through the data sheet, and they have some registers are they're shadowed, and you can write to them and read to them in one command. The data sheet has all this in great detail, so I'll leave it to them for how to interface. So this is what's interesting is it's pretty well spec'd, It can drive up to a 1 kilo ohm load in parallel with 2 microfarads. So like you can really abuse this. And another thing I thought was really neat is you can compensate it so you don't have to worry about having overshoots. You can also do slew limiting on the output. So again, if you have very long transmission lines, you don't have to worry about like, can I drive this capacitive load without worrying about having overshoots or ringing. It's something that's built into this chip that can manage it for you. So again, if you're not a hardware analog person, a lot of the stuff that normally you'd have to deal with in the field, have like trimmer pots and like maybe adjust values depending on like the cabling and enclosure, it's all done in firmware for you. So it'll save you a lot of time and money and field rework. There's also a ton of fault outputs. On the right is the fault table. You can see all the different things that it will warn you went wrong. Unlike very simple DACs that cost $1, where you write data and it doesn't tell you anything. It's like the data's out, output. Good luck. You'll have to do any feedback management or error management. It does all of it for you and can give you warnings. The fault management covers like pretty much everything, including, I thought was nifty, is there's a built-in temperature monitor as well. It's not like a temperature sensor, but you can tell it like, hey, if the temperature of the die goes above this, set the fault. So it can self-monitor its own temperature. Again, like little details like this that I'm like, wow, yeah, if I'm doing something in robotics or automation or something industrial that's outdoors or in a car or in a train, safety is very important, reliability is very important. I need to know when something has gone wrong. Think of all the things that you would have to keep track of that can go wrong, that you would require extra external circuitry, temperature sensors, or feedback op amps, or like compensation loops, or whatever. You don't have to do it. Again, it's all built in. There's also this kind of neat. They have an internal oscillator diagnostics. So the internal processor inside has a 1 megahertz clock rate, and it will automatically like update a counter inside, and you can read that counter, and that will let you know if due to temperature or maybe physical stress, the oscillator is out of sync. So I thought that was like kind of neat. Also, you can send like this cool 07 dead code. So interesting. Another nice thing I noticed is if you want to do like a software reset, you don't just like write a random value to register, because of course you could accidentally set it. You have to be very specific. There's like multiple commands you have to send in specific order in order to do a software reset. So if you're writing the firmware, it's really easy, but you don't have to worry about your code jumping to the wrong location, data accidentally getting corrupted, a loose connector, accidentally sending a soft reset, and the whole system flies back to the original location, possibly damaging itself if it's connected to like some gigantic servo motor. And finally, there's an eval board. I picked one up, but it pretty much looks like this. There's like this connector on the side. Looks like there's a development kit that it can plug into, but it breaks out all the pads and connectors, and then the power supplies go onto the top. So I think, yeah, if I think this chip is great if you're an electrical engineer. You do not want to mess with analog. You don't want to have the risk of have something going wrong with the analog section, and you want to sort of depend on the people who know what they're doing, analog devices. It's pretty clear that they've seen every possible failure and added a fault mode or like a feedback register or some self-monitoring hardware. Everything that I saw was like, oh yeah, that could happen. But if you're an engineer, you may not think of all these things that could happen to your hardware. If you go to the data sheet and just do everything they recommend, you're going to be way ahead when it comes to reliability testing of your hardware. So,
like at some point, an FAQ can eventually become silicon.
Yes. No, pretty much. Like every time they had a customer say like, your thing broke, and they're like, well, what happened? Oh, it turns out the die, the oscillator got, so the chip got hit. It got vibrated, and the oscillator got out of sync, and now it's not working quite right. That would have been caught by the oscillator monitor. I've never seen an oscillator monitor before, but it must be there for a reason. So, like, if you use this chip, add that test, right? Every watchdog cycle, check the die temperature, check the oscillator monitor, check the feedback monitor. All these things that they have, put that in. I also like that every time you read data from a register, the fault bit is the top bit. Like they force you to look at it. They're like, look at these errors. Look at this thing that could have gone wrong, right? That you can't escape it.
Must be fun to make something that lights it all up. Like everything just failed.
It tells you when something's
Yeah.
gone wrong. So, high reliability electronics, I love seeing it. I deal with a lot of my electronics are, to be honest, they're not high reliability. They're not designed for it. They're kind of meant for consumer electronics. So taking taking a look at this kind of electronics, and you're not paying military prices. It's still consumer prices, but you get good industry reliability in this chip.
All right, it's available on DigiKey. Go to DigiKey site. Short URL is digikey.com/PBQZCHNR, or you can just search for AD5413BCPZ.
That's right. Or AD5413.
And then is this week's NMPI. Okay, let's jump right into new products.
Okay.
Since we're right at 9 o'clock. We're running a little late this
we gotta
week.
go. Okay. Go.
All right, here we go.
Okay, first up, we have this super skinny thermistor. We've actually stocked thermistors for quite a bit. This is a 10K NTC thermistor. It's just like really skinny and really small. So it's perfect for if you have to like measure the temperature of something where you can't fit a DS 18B20, you can't fit an MCP 9808, whatever. This thing is so slim. Maybe I'll show on the overhead how slim it is.
Yeah, do it.
Okay, so this is the overhead. And this is so skinny. I mean, it's like, in the specs, I think it's like a 0.5 millimeter or something. Very, very slim. There's a little bit of a bump where the sensor is, but it's very slim. So if you measure this with a multimeter, it's going to be 10 kiloohms at room temperature. And then as it gets warmer, I think the resistance goes down or goes up. I can never remember. Check our tutorial we have on thermistors. We have a tutorial on using these kinds of thermistors. You'll want a 10K 1% resistor to go with it as a resistor divider. And then you measure the resistance. You measure the voltage made by the divider. The voltage goes up and down based on the temperature. And then we have some Arduino code that you can use to convert that back into temperature.
Okay, next up.
Okay, next up, we've got this really cool Lincoln Bins case. And here's, there's like, we have so many Raspberry Pi 4 cases. You're like, what is great about this? The great thing about this case is it brings all the ports out to one side. Oh, bring it back. So you'll see, if you look at this, you're like, oh yeah, there's like the Raspberry Pi Ethernet and USB ports. I'm like, wait a minute, the power and HDMI are right next to it. How is it doing that? I'm glad you asked. So what they do is they include this little like adapter thingy, that green board at the top, and when you plug that into your Pi 4, it turns it into all the ports in a row. So I thought I would show this on the overhead.
It's a good idea.
Yeah, this was like the killer. Wait, you zoomed in so much. Wait, you didn't zoom in so much. Okay, so this is the adapters. This is my Pi 4, right? So it's under this metal case, which is, this metal thing is like a little protector thingy. So when you slide it in, and you can see here, these are the HDMI and USB, and then there's over here, so that it all comes out one end, and then this slides in nicely into the enclosure. The enclosure is metal, the ends are plastic. Why? So that the Wi-Fi can get out. So this is a cool Pi 4 case.
Okay.
I just love that all the ports are on one side. That's going to be very useful for somebody. Maybe me.
Yeah. All right, next up.
Okay, we've got more compute modules are slowly trickling in. This is the compute module 4 for the Raspberry Pi. This one has 16 gigabytes of onboard MMC flash, so you don't need an SD card with it, so you can save $10. Don't need an SD card. Has 2 megabytes of RAM, and it has Wi-Fi, and it plugs in nicely into the whoa, so much stuff on here. The compute board. So this is the compute I/O board sold separately, as they say in advertisements. It gives you the HDMI ports, the Ethernet, the USB, SD card, PCIe, GPIO, multiple camera, and display ports, and like power supply and all that good stuff. So it's a good development environment. And this is the module itself, which I'm going to delicately remove. It's got the Hiroshi connectors on the bottom. They plug into here. Here's the Wi-Fi port. Here's the Wi-Fi chipset underneath. Power supply is over here, kind of like a cool little like domino look. This is the RAM is on top. This is the flash memory, and this is the power monitor. This is Ethernet. What is this? I don't know. What is it? The BCM. I don't remember what that chip is. I thought it was Ethernet. Maybe it's a power monitor or it's a controller or something. But yeah, this is the full Raspberry Pi compute module. So the ones we had already did not have Wi-Fi. What's nice is that there's a built-in antenna. We also sell the antenna kit. You plug in the UFL and you get the pre-certified antenna. So that will speed up your certification process. And then you start development on the compute module I/O board. Has everything. And then when you're ready to go to manufacture, you just, design your board, take away all the things you don't need, keep the things you do need.
All right. Next up.
Okay, finally we have in stock the Hi5 Inventor Kit. Yay! So if you are interested in RISC-V chips, you want this happy hand that's Doctor Who themed. It has multiple RGB LEDs on the front. It comes with connectors and this case and a speaker, USB battery and everything. There's an online teaching system. So we've actually previewed this, and if you see our other video, for this product, you can see it live. But we finally have them in stock. There's an online system for programming it. I believe there's also maybe MicroPython available for it. And also, if you want to do low-level development, there's ST SDK. So, you like Hi5, RISC-V chips, you want a development board that has everything built in, can be used by kids and adults, here you go.
Okay, and last up to start of the show tonight, besides you, Lady, our community, our team, our customers, is
the Raspberry Pi Pico pin reference. Yay, we ordered this. They finally came in. So we're going to probably pack these in with some of our Raspberry Pi Picos when we get more, which we don't know when that is. But when we do have them, we'll probably, maybe we'll include them in some orders. This has a quick start guide on the back, how to get started with CircuitPython, including some CircuitPython code. So you're like, how do I blink the onboard LED and print to the serial monitor? A quick start guide on the back for CircuitPython. And on the front, it is a life-sized pinout diagram. So the Pico has the Raspberry Pi aesthetic, which means it does not have GPIOs labeled. So I have one of these cards on my desk, and I use it every day. It has, all the GPIOs and the peripherals. Like, is it an I2C pin, or can you mux it with the UART, and which PWM output, which ones are the power pins, and what power output. So this has everything on it. It's life size, so I can even show on the overhead. It's, you put the Pico on top, and hold on, let me focus. There you go. And you can zoom in. So this is the Pico, goes on top up here, and then you can see all the labels. So GPIO labels and all the capabilities, SPI, I2C, etc.
Yeah.
And then we got some notes here about what the power supplies do, and then a color code as well. And that's my favorite new product.
all right. Okay. Bing. That's new products. Okay, so now let's do some questions. I have some lined up, but we're gonna do top secret.
Okay. Oh yeah, I gotta get my top secret out.
Yeah. All right, this week's top secret. Put on the overhead.
Okay, I've been working on keycap breakouts. So I'm doing like mechanical keyboard type stuff. So this is a little breakout board for, this is a Kale box switch. So a little mechanical keyboard switch, and they used sockets. I got the LED backwards. There's a little bit of wiring here, but it's gonna have an LED that sticks out and can like underlight the keycap. And it's got a socket, so other than the fact that I hot glued this in, you can remove it and swap out whatever key you'd like. And then I have a little demo. So yeah, so I have this little like cute, adorable kitten paw keypad, and it's got silicone nubbins, like little toe beans. And what's cool is that, of course, the LED, the NeoPixel underneath, which is controllable, shines through the toe beans quite well, so you can get, let's see, glowy beans There you go. This is what everybody wants. This is what I want. I just want like glowy toe beans.
All right.
All right, so that's the top secret for tonight.
That's top secret. That's top secret.
That's top secret.
Okay.
Back in the vault.
I'm gonna read off these questions. We do this over on Discord, adafruit.it/Discord. Join us. All 28,000. All right, I'm gonna start reading these off. Let me get the latest one.
Okay.
You ready?
Yes.
Okay, we'll speed.
Oh
run
my
these.
God, there's so many questions.
Oh, for the bundle manager or the library manager, could we support the CircuitPython community bundle?
Yeah, it'll support both.
Okay. Any chance that the package manager can optimize the order of import for lowest memory usage? Might not be possible. Would be nice. I guess sort by.
You can't because it's just installing it. It's not writing your code for you. But we could add a thing that tells you how big the MPY file is, and then you could use that. It's not exactly the same, but it could give you a hint.
All right. Someone's asking about the I2C scanner tool. Yeah, that's not out yet. It's called Stem.
Yeah, I took a break from that. I'll get back to it
Yep.
though. Don't worry, there's other good stuff coming.
Folks like to see the Collins Lab notes, different types of PCB
Okay.
as a request.
Yeah, sure.
Okay. Has a Raspberry Pi Foundation said anything when they expect more RP2040s?
I have zero idea.
There you go.
I don't know anything you don't know.
That's right. What can I use to have a logo I created light up on a bracelet activated when the bracelet's put on?
Check out the circuit sculpture project that Jepler just posted because you could probably make the bracelet out of wire and use that as the capacitive touch. And when you wear it, the NeoPixels glow. That's pretty much the project he did. He made a pendant, but you would just make it into a bracelet.
Okay. Someone wants to use a 64 by 32 RGB panel. They want to use it on a school bus displaying route numbers. They want to get the GPS and then automatically switch the numbers from the location of the bus. Any help? Yeah, that's a
a
cool
lot of
project.
math. I mean, you can do it. I think you're just going to have to do, you're probably going to wire it up to the GPS and then, use that to take data. While the bus is on the route, you'll have to take the data of what the route is and then save that to a file. And then what you'll do is, it can, when it's running, it then says, like, am I within, 20 meters of one of these points? And if so,
Yeah.
it
You can do it
knows
with
where it is.
CircuitPython.
You can do it. It's just,
Yeah.
you have to collect all the data and then compare
Yeah,
it
you're
to
making
it.
a data logger, saving it to file, and reading it, and you have predetermined places where geofencing.
Yeah.
Okay. All right, next up. Question for show later, if I remember correctly. Adafruit contributed to the amplitude shift keying Radiohead Arduino library. Two-part question. Do you plan on reusing the code for Raspberry Pi Pico? And the other part of the question is, how hard is it to get a working Arduino library like the RH_S to the Raspberry Pi Pico?
Yeah, I did write Radiohead. I didn't actually add anything to that library. I just made it compile and I put it on GitHub. You need to talk to the Radiohead library writer if you want to add Pi Pico support because that's totally beyond my capabilities
Would
and
the
time.
DACs that we showed work to replace digital pots in a virtual joystick?
You could, especially if you wanted to, there's more code. You'd have to write the code for it. It's not easy, but if you did, you would have a very reliable DAC system.
Okay. Several weeks ago, you pointed someone to a MCP 23008 port expander. Thank you again. How do you remember all the chip names? Any tips?
You just use them a lot. I don't know.
Yeah. All right. Next up, will there be a card for the Feather, a printable card?
I don't know that I'll need a card. I'll tell you why. Because the Feather has the pins labeled on it, so you don't really need a card because you can just look at it. The Pico doesn't have the pins labeled, so you kind of need a card. And if people really need a card, I feel like a lot of times these cards just get tossed out. So unless I think they're really needed, we don't make them. Instead, we have really good documentation online. But again, the pins are labeled online.
Okay. Any other upcoming boards at RP2040? We have Ditsy Bitsy, Cutie Pie. Yep.
That's all I got so far.
Yeah.
In the design queue.
They also want to know, would there be an ESP32 Cutie Pie?
Yeah, there's a ESP32 S2 Cutie Pie.
Right. Okay. What's the best way to clean a solder stencil that contains very small holes?
You compressed air and soaking it with isopropyl alcohol.
Okay. I'll answer a couple of these. Yeah, items are out of stock. Are they going to be in stock soon? Yeah, well, obviously we'd
Believe me, I would love to.
Yeah.
I can't. I just got a quote today for one of our gyro chips that I normally buy for $1.50, and the broker came back with $23. Like I can't buy a chip for $23. Like it's not available till
Yeah.
December. So like that gyro, we're just not going to have in stock until I can get them.
Yep. All right, and then I guess a general question, because it'll apply to either MicroPython or CircuitPython. Can you protect your code with like a encryption or something, or
No, the code itself you can't really protect. I mean, you could do a lot of effort and maybe add encryption layer, but it's kind of not worth it. There's with C code, there are some chip protections. If you're writing a hex file, but part of the trade-off of having a interpreted language is the interpreted language has to be in text. So
Yeah.
you can't have both. That said, if you have a Raspberry Pi computer, you can't protect the code on that either. Really, the code's running on it, and it's a disk drive. You can just pop the SD card into a computer. So figure out other ways to protect your
Yeah.
code or intellectual property.
All right. Next up, do we sell shirts now? We don't do shirts. I think we had a couple shirts. We
Yeah,
try-
sometimes.
And let's see. Bill sent Katney the feather diagram, the feather pinout for the
Oh, great.
RP2040.
Yeah,
So we
yeah.
have that.
Use that.
All right. And then, do you guys have a breakout board to put NeoPixel addressable RGBs
No,
on?
you're on
You
your
saw
own.
this. Okay.
I just thought they were cool.
Okay. All right, and I think with that we got through. Is buying from Mauser or DigiKey still encourage you guys if it's safe for donors? Yeah.
It's good. Please support our distributors. We always appreciate folks who buy direct as well. If we have it in
Doesn't
stock.
matter. It doesn't
Good.
matter because all of the large electronic suppliers, they buy lots of our stuff, and we like to do partnerships with them. And then when they see demand there, they order more stuff, more of their customers. I heard from some of the larger companies that it was something like 1 out of 5 orders had Adafruit stuff in it. It was like a really big number.
Yeah,
That was
yeah.
good to see in here.
All right.
Okay.
Thank you, everybody.
That's our show for this week. Special
do more questions next
thanks-
week.
Yeah, we got to all of them. We just finished them. Let me make sure. Yeah, we got to them.
Okay, great.
Special thanks to Takara, who's behind the scenes in Slack. Special
Thanks,
thanks
Takara.
to all of our Adafruit team members, all of our Adafruit customers. Don't forget, we're shipping stuff smart and safe. Please place an order on Adafruit.com, support open source hardware and more. And we'll see everybody next week. Here is your moment of Zener.